Hello friends, welcome back to our channel. So in today's session we'll discuss about one more concept in discrete mathematics, that is types of recurrence relations. So in our previous session we have discussed about what exactly mean the recurrence relation. So with a quick overview, so the recurrence relation is defined as the current term will be defined with a recursive manner from the previous terms. Okay, that we call it as a recurrence relation, and we have seen different examples of recurrence relation and also the applications of recurrence relations. So now without delay we'll start today's session, that is the types of recurrence relations. The types of recurrence relation. So majorly these recurrence relations are classified into three categories. One is based upon the linearity, the second one based upon the homogeneous, and the third one based upon the order. So the first one, linearity. So under the linearity there are two things. One is linear recurrence relations and non-linear recurrence relations. So we'll see one by one. And the second one is homogeneous. So under that we are having a two categories, homogeneous and non-homogeneous. And the third one is by order. So under that there is a first order recurrence relation, second order recurrence relation, and similarly higher order recurrence relation. So these are the different categories of recurrence relations. So based upon the linearity, homogeneous, and order. So first coming to the linear recurrence relations. So this linear recurrence relation will be having only the combinations of linear terms. So I'll erase all things. The first we'll go with the linear recurrence relation. So what is this combination of linear terms? So that means no powers and no multiples. Okay, no powers or no multiples, right? So that we call it as a linear. So for example, let us take one thing. So some x power n is equal to some x plus some y plus some z, or see, x1 plus x2 plus x3. So this is called a linear recurrence relation. So here we can see there is no power. So x1 always we are having only one power 1. So there is no powers of x, and also there is no multiples. So if this equation is having like this x1 square plus x1 into x2 plus ex2 square, like this, in this form, this we should not call it as a linear, because it is having powers and also it is having multiplications. So only these kind of relation is called as a linear. So there will be no powers as well as no multiples. So generally the syntax or the example for this one is, so as we said that the recurrence relation is defined as defining the terms in a sequence recursively. So we can write it as xn is equal to some c1 into xn minus 1 plus c2 into xn minus 2 plus c3 into xn minus 3 plus and so on. So here there are no powers, where c1, c2, c3 and so on are coefficients or constants. We can call it as a constants. Instead of coefficients, we can call them as a constants. So all the c1, c2, c3 and everything we call it as a constants. So here there are no powers and no multiples. Here we are having a multiple, but this x is multiplied with a constant, right? So there is no problem with that. Okay, so that we call it as a linear. So obviously the next category is a non-linear. The next category, the next type of thing is a non-linear recurrence relation. So hope you understood about the linear recurrence relation. So the next one is a non-linear recurrence relation. So the quite opposite for the linear recurrence relation is the non-linear. So it will be combination of linear terms, comma, powers, comma, multiples. Then we can call it as a non-linearity. Okay, so that means if it is like xn is equal to some x1 square plus x1 into x2 plus x2 square, like this, if there are any powers as well as the multiplications, or you can also go with the x3 plus x4. So some linearity as well as some powers as well as some multiplications. So if any equation is having in this way, that means the combination of linear terms as well as the powers and the multiples, then simply we can call it as a non-linear recurrence relation. Okay, for example, so any linear equations you can see x square plus y plus z square. So like this is also a non-linear recurrence relation. Okay, so in general we call it as xn can be defined with c1 into xn minus 1 square plus c2 into xn minus 2 plus c3 into xn minus 3 whole cube, etc. So this can be considered as a non-linearity. So here not only the simple terms, we are also having the powers, and if possible we can also have the multiples. So this is the non-linearity. So if any equation you found in this way, we can say it as a non-linear recurrence relation. Yes. Now let us move on with the second category, that is homogeneous and non-homogeneous. Homogeneous and non-homogeneous. That's also very simple. So homogeneous recurrence relation. So which recurrence relations, or when the recurrence relation is called as a homogeneous recurrence relation? So if the current term only depends upon its previous terms and independent of any other term. Okay, so if a current term totally depends on previous terms, then we can call it as a homogeneous recurrence relation. So this can be considered as some a n is equal to some functionality of, so a n minus 1 comma a n minus 2 comma a n minus 3 comma and so on. So we said that any recurrence relation, so the current term will be depending on some functionality applied on the previous terms, that we call it as a homogeneous recurrence relation. So for example, you can go with the Fibonacci series. We know that initial conditions a not equal to 0 and a1 is equal to 1. So what about a2, which depends upon only a naught plus a1? So that means an is depends upon the function of a n minus 1 comma a n minus 2. So other than these two terms, we are not depending upon any other term. So such type of things we call it as a homogeneous recurrence relations. So the current term depends upon only the previous terms. Only the previous terms. So even we have seen one example like a Lucas sequence. So there also the current term will depends upon only the previous two terms, but the initial values will be different. So that's the only difference, right? So such type of recurrence relations we call it as a homogeneous. Now the quite opposite of this one, that is a non-homogeneous. So when the recurrence relation is called as a non-homogeneous, so if the current term totally depends upon previous terms and other terms and other terms which are not previous terms. So other than some previous terms, if it depends upon any other terms, then it is called as a non-homogeneous recurrence relation. So example you can see, so similarly an, the current term depends upon function on previous terms and so on, plus sum of some n. So let it be, so a n is equal to some a n minus 1 plus 3n. So you can see a n minus n is a previous term, but 3n doesn't depends upon the previous terms. It's a constant, right? Similarly, the current term is equal to a n minus 1 plus n square. So this is also not depends upon the previous term. So a n minus 1 is a previous term, but n square doesn't depends upon any other previous terms. So if the relation, the current term depends upon the previous terms as well as some other independent term, then we can call it as a non-homogeneous recurrence relation. Just remember this formula: an is equal to f of a n minus 1 n minus 2. That means all the previous terms with addition to some non-dependent of previous terms. So it can be 3n or n square, or simply it may be a constant a n minus 1 plus 4. So this is also constant. This doesn't depends upon the previous terms. This doesn't depends upon the previous term. This doesn't depends upon the previous term. So such kind of things is called as a non-homogeneous recurrence relation. If the function is in this way, a n is equal to a n minus 1 plus 2 a n minus 2. So then it will be a not homogeneous recurrence relation, because this is a previous term and this is a previous term. So if you want to get the current term, we have to apply the function on only previous terms. But here we have to apply the function on previous term as well as some other independent term, so that some other constant. So such type of recurrence relations we call it as a non-homogeneous recurrence relations. Hope you understood this one. So later we in our further sessions we'll be solving a few problems on these kind of things. So linear, non-linear, homogeneous, non-homogeneous, like that. Yes. Let us move on with the third category, that is order. Order. So first order, second order, as well as a higher order recurrence relations. Okay. Now, as the name itself indicates, the first order recurrence relation. So this is the order. The first one is first order recurrence relation. First order recurrence relation. So the name itself indicates the first order means the current term will completely depends upon the just previous term, one previous term. So current term depends on only one previous term. So it can be represented as an is equal to an minus 1. So this will be depending on only the n minus 1, where n is greater than or equal to 1. Greater than or equal to 1. So n should not be 0. Okay, n should not be 0. N should be minimum, n should be greater than or equal to 1. Right? So you can also write it as an is equal to an minus 1 plus 3. This is also the first order, because this is a non-homogeneous. Okay, it's a non-homogeneous, but it only depends upon the previous term, n minus 1 term. Okay, so how to find out which order of this given relation? So finding of order. How to find the order? Finding of order. How you can find means, that is a difference between, remember this one, difference between higher subscript and lower subscript. Higher subscript and the lower subscript. Okay, so this is the most important thing. So here we know an, this is the subscript. A square, this is the superscript. Okay, just remember. So this is the subscript. So here n is a subscript and n minus 1 is a subscript. But if you are having a square plus b square, 2 is a superscript. Okay, so here the finding of order. If you are having any equation and if you are, you are supposed to find the order, so simply you can go with the difference between higher subscript and lower subscript. For example, this one, what is a higher subscript? Higher subscript is n. Okay, n. Lower subscript is n minus 1. So n minus n plus 1. So, or simply you can write it n minus of n minus 1, which is n minus n plus 1. So, what is the order? First order recurrence relation. That is a first order recurrence relation. So, higher subscript and lower subscript, we need to find out the difference. Hope you understood about the first order recurrence relation. Now, we will go with the next one, that is a second order. Simple. Second order depends, current term depends on two previous terms. Okay, it depends upon two previous terms. So two previous terms means an will be depending on an minus 1 and an minus 2. So nth term will be depending upon n minus 1 and n minus 2. So where n is greater than or equal to 2. N is greater than or equal to 2. So here also you can find the order. You are having an equation in this way, and if you are want to find out the order, which order this equation means, so what is the highest order? N minus lowest order n minus 2, which becomes n minus n plus 2, which is second order recurrence relation. So this is the very important thing. If any equation is given and if you want to find out which order it is, simply make sure the difference between the higher subscript and the lower subscript. Subscript means this one, right? So second order always depends upon the two previous terms. That means nth term depends upon n minus 1 and n minus 2. Next, so other than the second order and the first order, all the remaining will comes with the higher order. So higher order, you can see it depends upon previous 3 or more terms. So if the current term depends upon the previous 3 terms, then it will become the third order, right? For example, let us take this one. So if it is like this, a n minus 1 plus a n minus 2 plus a n minus 3. So where n greater than or equal to 3. So that is most important. N should be greater than 3. N should not be 2. So if n becomes 2, what happens? So this becomes a1 plus 2 minus 2, a naught plus this becomes a minus 1. So this is an invalid term. So always, if it is a third order recurrence relation, n should be greater than or equal to 3. Now you can apply. So what is the order of this particular recurrence relation means higher subscript n minus lower subscript n minus 3, which becomes n minus n plus 3, which is 3, third order. So other than the first order and the second order, all the remaining comes with the higher order. Either it may be a third order or a fourth order or a fifth order. And make sure the n value should be greater than or equal to that particular order. If it is a fifth order, the n should be greater than or equal to 5. and nth term will be depending upon 5 previous terms. 5 previous terms, and that may be either homogeneous or non-homogeneous. If the current term only depends upon the previous terms, then we can say it as a homogeneous, and apart from the previous terms, whenever it depends upon any other independent terms, then we can call it as a non-homogeneous. Right? So hope you understood these types of recurrence relations. So you must be very good aware about all these types of recurrence relations, then only we can solve the problems on different kinds of recurrence relations. So in our further sessions we'll see or we'll solve the different kinds of problems on recurrence relation. So we have seen the different types, that is based upon the linearity, based upon the homogeneous property, and based upon the order. So all these categories we have seen, and we have also seen different examples for each and everything. So let's stop here, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.